All right, find all numbers giving a remainder of 2 when divided by 3. So that means I want to have x is equal to 2 mod 3. And remainder of 3 when divided by 5, x is also equivalent to 3 mod 5. And this one is also an equivalence statement. We could use our equal sign or our equivalence statement here. They both imply the same thing. So I want to solve these. One thing I could try to do, especially with nice small numbers like this, is just make a list. So my first number, of course, is going to be 2. And then my next one, I'm going to add 3 and get 5, 8, 11, 14, 17, 20, 23, and so on. These are all, of course, multiples of 3 plus 2. And then thinking about this one, I'm going to have 3, 8, 13, 18, 23, 28, and so on. These are all multiples of 5 plus 3. So if I want to solve my system, I can see some solutions. So the first set of solutions I see is 8. And then I can also see 23. So my next one, notice my distance is 15. My next one would be 38. I would have for both of those. So really what I'm seeing is that my solutions are equal to 8 plus multiples of 15. So let me pick another letter here, P, let's say. Right? So what we want to try to think about is a way to come up with a systematic way of solving so that we're not just making lists. Well, notice that 3 times 5 is going to give me what I'm increasing by. And then my 8, well, to get the 8, we added 3 plus 5, but is that actually true? So for sure our 15 is coming because of our multiples of 3, multiples of 5. And I would go on to say that perhaps that's the GCD of these numbers. And the 8 we're going to think about as well. And we're going to do that in the next video when we come up with a system for solving the Chinese remainder theorem.